Welcome, everybody. We are super excited to have you here. This is a rather special community call. We're really excited about it. We will start the February edition of the community call. Welcome, everybody. We are super excited to have you here. This is a rather special community call. We're really excited about it. I'm guessing we have a number of new faces in this call today. And so if this is your first time here, that is great. We love having you here. I'm going to actually just drop a poll because it would be kind of fun to see who actually is first time here. And so if you want to answer that, feel free. But what we do is we have these community calls every single month, last Thursday of the month, 9 a.m. Pacific, where we have a review of the features we launched over the month. We have sometimes sneak peeks about what's coming up. When we have really cool, really big news to mention, we sometimes have little talks about that as well. But it's just a chance for us to kind of let the community know what's going down at Hasura. So welcome, and we're happy to have you here. So if you want to fill out that poll, that'd be great. But we will start the call, which basically we'll start with a special AMA and some announcements this week from Tanmai. And then we'll be going into some community demos of features, and do our typical spiel. All right, quick thing is, who am I? I'm Jesse. I do community outreach here at Hasura. That's about all you need to know about me. We're going to skip right along because we have a full agenda today. And we'll start up with the first thing we have today will be the Hasura update from Tanmai, followed up by a special AMA time where you can actually ask whatever questions you would like to have answered live on air. We will definitely pick and choose, but you can ask whatever you would like to ask, and likely we'll pick your question. We'll be then having a couple of really cool demos, replicating existing APIs to Hasura, quickly spinning up cloud preview apps, REST connectors update, which is again just a fantastic feature. It's like my little favorite one. And then we're going to have a really cool community showcase from Hasura Deltas created by Ace, which is a really cool demo too. So super excited about that. Without any further ado, I am going to invite Tanmai onto the stage here, and he can give a little update about what's happening in Hasura land. Tanmai, how's it going?
Hey, everybody. So yeah, just happy to kind of be here and do a quick AMA as well. I think on the Hasura update front, there's our biggest update, and it's just say we have a slide, is we just announced our fundraise, which sets us up for executing over the next year or two really well on just all of the stuff that I think we've been looking forward to from a product engineering standpoint, from a community standpoint, and allows us to kind of scale our operations up. So I'll kind of get into a little more detail of kind of what our plans are, and what you can kind of look forward to over the coming year. And then of course I'll also talk about a pattern that we recently worked on with a customer to bring in existing APIs, and so we talk about that after that quick fundraising update. So with that, before we kind of start, just want to take a moment to acknowledge the situation that's happening in the world today with Ukraine. And you can express our love and support in whatever way we can to folks who are affected. Any kind of war-like situation is terrible for everybody involved, and that sucks. It kind of broke our hearts a little bit when we sent out our community email and for people to join into the call, and we had a few folks who responded saying that they couldn't join because of the situation right now, and our hearts go out to them. But yeah, just want to take a moment to kind of acknowledge that reality in the world today. In our news on the fundraising side, just kind of wanted to give you folks a sense of the stuff that we have planned. I wrote up a little blog post about kind of the stuff that we're going to be, the stuff that we're up to. Just to kind of go through that with you folks here, over the last year, we had we put a lot of focus into kind of building out our the managed service on Hasura Cloud. It's still work in progress, but it's been an amazing amount of effort to stand that up, to build out the enterprise version of our products as well, working closely with our enterprise users, and kind of based on that growth, it was really important for us on that commercial side to establish a foundation for kind of the long-term health and success of Hasura, right? Without which, our company would not exist, without which we would not be able to maintain and support the open source project, and kind of keep working with the community to kind of keep adding features and keep adding support from our databases and stuff like that. So that was kind of most of our work last year in kind of setting up that initial foundation, in growing out our engineering teams, in growing out our product teams. What we've kind of been able to what as a company, right, of just about 100 people now, what we've learned over the last few years is that people and our users really like using the Hasura GraphQL API. It's a powerful API, and people want to use it for a lot of different use cases and in a lot of different situations, right? That they kind of want that data API in. What we've also learned is that because Hasura occupies such a critical portion of the stack, there's so many use cases and kind of day-to-day things that you encounter while using Hasura, that you also kind of want as improvements and as enhancements or as new capabilities that are getting added to the product rapidly, right? And it's important for that to move as quickly as possible, because Hasura is essentially kind of the API for your stack, right? So you want that to keep getting more and more flexible, to keep becoming more and more powerful, for the experience, the day-to-day experience of using Hasura to become easier and better, right? And so that kind of essentially informs our focus going forward as well, right? Our big plan is to basically, the way I talk about it is to just help our community and our users take Hasura to all of the places they want to take Hasura to, and to keep working with them as quickly as possible, with as much velocity as possible, to keep solving for the problems they're encountering, even day to day, right? So as you kind of encounter those problems, and accelerating our product development velocity to kind of meet your needs, right? And to meet our users' needs. So that's kind of the key. That's kind of the key theme for us over the next few years, and we're happy to kind of be able to partner with investors who understand the open source journey, who understand kind of this infrastructure piece of the puzzle that we're working on, and support us and support our community in building this out. I think in that kind of broad theme, one of the things that we're going to be really excited about launching or talking about at HasuraCon this year, which is set on June 20th, and you should register for that. And one of the things that we'll announce there and talk about more detail is something that we've not done before, but a way for us as a community to contribute to Hasura, and to add support for our favorite data sources, whatever it is, whether it's a database, whether it's a service, or whatever it is, to Hasura. And we haven't talked about this yet; it's a little bit hush-hush. But as we kind of get closer to the date, we start seeing more material around it. It's essentially kind of taking out our internal interface and making that open so that everybody can kind of contribute incrementally to Hasura for their favorite data source, right? And because it's incremental, you can kind of start adding features and start using and getting Hasura features on your data source in an incremental and usable way, right? So you can start off with, say, reads with permissions, and then gradually add subscriptions, gradually add permissions, and permissions would be an initial part of what you'd want, the subscriptions, and then gradually add mutations, event triggers, and so on and so forth. So that's going to be a big area of work for us on the product, engineering, and community fronts, to kind of work with vendors and partners and community members and users in kind of working on support for these data sources together, right? the reason why I think this is really important to us is because when we think about open source, right, and how open source is important, open source is not just a marketing thing of kind of saying that, hey, it's open source, so come developers use it, right? And then sometimes what tends to happen, and this is obviously very nuanced and hard discussion to have, but often as developers, we see projects that are backed commercially change their license, right? For reasons that make sense, but it's confusing, right, to the users, to the community, to other people, right? It's a very tense problem. But for us, it's really important that the open source project that we're creating, right, it feels like it's a part of the community where the community has ownership of pieces of Hasura as well, so that they can kind of add to Hasura too, right? And that's really important, and that's one of the key reasons why Hasura is an open source company, right? Because evolving Hasura to kind of keep up with the future can only happen if all of us work together to own pieces of Hasura, right? And to be able to use it the way that we want to, and to be able to make it move in the direction that we want to, right? And so that's kind of a critical part of what we want to do, and we'll be seeing a lot of work around that this year. The other stuff is kind of usual, more company building stuff where, basically investing in product and engineering to accelerate that. We want to be much faster than especially last year when we were doing a lot of the setup work. We were not as fast as we would have liked to have been in responding to in responding to some of the more longer term needs that we wanted to build on the product for our users. And this year now we'll be accelerating that again. One of the things that we've done is, we now have a release every 2 weeks. Hopefully we'll be able to move that to an even kind of faster release cadence, and especially being able to opt into the latest releases on Hasura Cloud is a big piece of work as well, so that you can kind of keep benefiting from the latest and greatest in a safe and simple way, right? So that's going to be a big focus on product and engineering as well, apart from some of the bigger projects that we're working on. And otherwise, it's building out some of the other operational elements of the company. Our customer success team has been so critical over the last year in helping us work with our customers as they're kind of using newer features of the product, using new parts of the product. And they've just done absolutely incredible work in supporting the rest of the company and our users. And that's a team that we'll be also helping grow out, especially for some of our mission critical users, so that they have timely support. They have somebody that they can reach out to for help as and when they need to. So that's kind of a quick look at the stuff that we're up to. And of course, we're hiring. So please feel free to check out the Hasura careers page and send an application, refer friends, family, whoever, and that we love to kind of chat with them. But that's on the Hasura front. If there's any questions you folks have, happy to take that, and then just dive into some of the updates for our usual community call.
All right, so let's open it up for the AMA and see what we have for questions that might come in here. Just give it a 1 minute here to see what we have coming in. Otherwise, I know that we have a couple that trickled in over the last couple of days that we can also have a look at. So while we're letting everybody type their questions, so you were already speaking a little bit about the plans for what we're going to be using some of the funding for in terms of the direction and the future of the Hasura product and company. What's something you think that Hasura is going to be playing a role in terms of broader GraphQL adoption and awareness, just as an industry partner and player? Because we're one of the bigger ones in the ecosystem now. Like, what do you see us being able to contribute in the coming months and year?
That's a great question. So yeah, I mean, we're one of the founding members of the GraphQL Foundation. Financially contribute to the foundation as well. And via the GraphQL Foundation, there's a bunch of projects that the foundation supports to, on the graphical side, the work on the specification itself, work on the reference implementation, right? And so that's a big part of what we do. We, in addition to GraphQL, by the way, we also kind of do work closely with some of the other open source ecosystems, right? Whether it's especially Haskell, and contribute kind of to the Haskell community as well, both in terms of time and code, but also as financial support too. I think on the GraphQL side, especially with the GraphQL Foundation, which is kind of one thread of the work that we'll be doing in the GraphQL community. The GraphQL Foundation is a really nice place to kind of look at different projects that are happening and kind of get into certain projects that are good for the kind of overall GraphQL community. It's a neutral organization. It's done a really good job at kind of shepherding that spec in a way that has allowed the industry to kind of gradually evolve around a GraphQL specification without it getting pulled in one direction or the other. It's always a hard thing to do. And so that's been great. And they've also started, the foundation has also started maintainer programs, so that there's a kind of like a stipend and a maintainer fee that the foundation does give out to contributors and maintainers as well. So that's also started to happen. I think that's kind of one place where we'll continue investing and increase our investment there as well. I think on the other side of things, right, for us, making GraphQL available to as many people as possible is it's a great thing to do, right? Hasura is a great way to just try GraphQL out as well, right? You're not familiar with what GraphQL does. You want to see what GraphQL would look like if it's in your organization. You have one of the data sources that Hasura supports. It's great to be able to try Hasura and it's great to be able to try GraphQL out using Hasura, right? So kind of building off of that, right? One of the things that lines up very clearly with what we want to do as well. Make sure that Hasura is kind of supported everywhere, so that then people can use that to get GraphQL everywhere, right? And that's kind of very Hasura specific. But the third thing also there is that there's a whole set of new projects on the GraphQL side, especially on the GraphQL client ecosystem, some of the GraphQL exploration tools and stuff like that, that are great open source projects that are coming in the community. And what we've recently started doing is exploring how we can support those contributors directly, say via, for example, GitHub sponsorship, etc., and helping that part of the ecosystem as well. Both in terms of kind of open source partnerships, both in terms of and in terms of financial support them as well, so that they kind of keep maintaining that, right? It's always easy to start a thing and build a thing, and it's terribly hard to kind of keep maintaining it. And the open source reality of that is almost everybody is familiar with it. It's tough to be a maintainer, right? And so whatever we can do to help these kind of adjacent projects in the GraphQL ecosystem is something that we're thinking about a lot. Something that we've started doing a little bit of already, and we might think about how we can increase or amplify that over the coming months.
That's great. That's a really good answer. And I also want to just add as a shout out. So if you are like in the community here watching a GraphQL maintainer, you have some kind of project or library, whatever, reach out to us. Let us know what you're working on. We'd love to feature you or partner with you in some way. Join us on Discord, reach out to the community. The Hasura story is very much a GraphQL story. So we would love to hear from you and just raise your hand and let us see you if we haven't found you already, because we definitely have our scouts out there scrounging around and keeping our finger on the GraphQL pulse. So I would say for the rest of the Q&As at the moment, I think everybody was pretty happy with your intro to what we're actually working on here. So I would say let your AMAs inside of the chat. We'll try and take them as they come a little bit and maybe answer those in text. And with that, I would say, why don't you take us off with the first demo, because you've got quite the payload for us today in terms of something that you're pretty excited about. So
yeah. Just given that we had a little bit of the introduction, I'll keep our pattern discussion a little short. So let me quickly zoom through that, and then let's see here. Cool. All right. Can folks see my screen? I'm hoping that's yes. All right.
Yep, that's good.
Thanks. Cool. All right. So really kind of simple. This is for folks new to Hasura. I mean, well, this is a slightly advanced pattern of Hasura, or like different pattern of Hasura that we're exploring. So just kind of bear that in mind. But the problem statement here that we're looking at is basically saying, hey, we have an existing REST-ish API or a GraphQL API or something that exposes business objects from some system of record, right? Maybe it's a legacy system, it's a legacy database, it's an old service, it's 30 years old, 20 years old, whatever, right? It's a thing that exists. And what we want is you kind of want a GraphQL API on it, right? A Hasura style GraphQL API, the way Hasura works with Postgres, right? You want permissions, you want pagination, you want sorting, you want aggregations, you want relationships. Now, if you want to get this kind of an API, an existing REST API, it's hard because fundamentally, when you think about features like pagination, sorting, aggregations, relationships, filtering, right, the where clause and nested filtering and all of that, it depends on being able to operate on that piece of data, which is why Hasura kind of exposes those features on when Hasura is giving you a GraphQL API on Postgres, right? So that kind of becomes challenging for Hasura to do when that GraphQL API is just coming from another API service, and that API service itself does not have these kind of advanced capabilities, right? And so that's kind of the problem statement that we have at hand, which is that how can we start, what is a pattern with which we can get this Hasura style API, but on this existing API where we don't have any control, we know that it's exposing some objects, but we don't have the flexibility and the queryability that we would have gotten if that system of record had just been in Hasura plus say Postgres or Hasura and SQL Server or whatever, right? So when we think about that's the problem, that's kind of what we want. Just an important thing to note here is that if you use actions or remote schemas, you could use that to bring in an existing API as well and bring that into kind of like a Hasura powered GraphQL API where you would get things like caching, for example, and monitoring, but you still won't have that kind of advanced flexibility that you would get with say, row level or entity level permission system, right? That does a predicate push down, or the kind of performance enhancement that you would get when you do relationships and joins where you don't have n+1 problems and you just get a single query that fetches all of the join data, all of the relationship, all of the related data in one shot, right? You won't get that power, but you will be able to expose that as a GraphQL API, which might work, right? So with that caveat, right, like what we're thinking about is noting that we don't want to take this approach, but we do want a powerful API. What does that kind of pattern look like, right? So the idea is really simple. What we do is we'll take models. We'll first create our models in a Hasura plus Postgres system as if that was where the API was always going to be, right? So we design kind of our models in Hasura plus Postgres. We get the GraphQL API. That's the API that we wanted. There's no data inside this because it's not the system of record. The second piece of the problem then is to take that data from our existing API and cache it or materialize it, right, in our Hasura plus Postgres system. So that it's like a materialized view, right, for the API. It's kind of like a materialized view for the API. You're just kind of taking that data and keeping it in a Hasura plus Postgres model. And then, of course, you get to use the Hasura GraphQL API, right? So that's kind of at a high level what we want to do. The details here, of course, like, how do you keep the data in sync? How do you bulk load that? How do you bulk load all of this data? What happens when the data is old? What happens if the data gets deleted? Right? Those are kind of the challenges, and that's kind of what we'll take a quick look at kind of how we approach that problem. So what we have, I mean, just in terms of an architecture to lay that out for you, is that you have an existing API, and this exists. And then on the other side, what we've done is we have Hasura. We've set up some Hasura models with a Postgres database. We set up our models here, right? So one of the examples I'm going to show you is as if we had like a billing system. There's kind of a bill entity here. What we've done is we want like a GraphQL API for bills in Hasura, right? So what is that going to, that's the model that we set up here. The next piece then is that whenever data changes here, we somehow need that to start populating our data in the Hasura plus Postgres system, right? Oh, great here. This is exactly kind of the problem that you're looking at too. And so when we're thinking about this, how this works is fairly straightforward. What we do is we first set up a sync events table. So we set up a table in Hasura plus Postgres, which basically captures events that are happening, right, in the existing API, so that we can then use that to kind of keep synchronizing data inside our model, right? Think of it like this is our cache. This is the source of truth. When the source of truth changes, we need the cache to get updated, right? So what entities in the cache should we update and when is maintained in this events table here. It's a very simple table. And what it essentially does is it captures an operation that's happened, the name of the model that's changing, and the identifier of what has changed, right? So this is like saying, hey, a new bill got inserted. Bill ID is 45, and it got inserted. Or bill ID is 45, it got updated. It's a bill, right? So this tuple, this kind of 3 pieces of information, right, are sent to this model here to track the fact that, hey, this has happened. Now we have to do the next step of figuring out how we can synchronize this data here, right? So that next piece is basically a Lambda, like a data sync. It's a Lambda or a serverless function or a web service or whatever. And so that's it's a generic piece of code that Gavin and I worked on and set that up. And this is something that you can kind of use in your own system as well as generic. What this Lambda does is it basically gets triggered whenever there's a synchronization event here, and it then updates the data in our Hasura models here, right? So whenever this event gets triggered, this Lambda goes, fetches the actual source of truth, the raw data. So again, imagining that we had bill ID 45 getting inserted, this Lambda then knows, okay, this was a bill model. Let's go and fetch all of the actual data for 45, for bill ID 45, and then let's go upsert that in Hasura, right? So that if it's an update or an insert, let's use the Hasura mutation, the upsert mutation, right? And let's insert that in here so that we can then get an API off of it, right? That's kind of the high level architecture. And I just kind of quickly, I won't do too much of a live demo. I'll just show you what this setup looks like with the Hasura console for those of you familiar with Hasura, so that you can just kind of map that to how that works, right? So here, for example, I have a sync event table. This is kind of the name of the table that has these kind of synchronization events, right? That's the ID, that's the name of the operation, that's the name of the model, and that's the name of the operation that's happening, right? Now, as soon as this operation happens, it triggers an event, and there's an event trigger here, which is the sync handler, right? So that's the sync handler that's going to be triggered. Let me just full screen this, right? So that's kind of the event handler that gets triggered. Can you folks still see my screen in the Hasura console? Sometimes when I full screen it disappears. Okay, thank you.
Good, still good.
All right, cool. So as soon as an insert operation happens here, right, our Lambda gets triggered, and what happens is that the raw bill object gets inserted here, right? So as soon as there's a synchronization event that gets added here, right, I can insert one manually. I can have something coming in from any kind of queue that my existing API has, right? Maybe the existing API is publishing business events over an event bus, over Kafka, over whatever, or maybe it's just calling out to maybe it's just making an API call, right, to say, hey, something has changed, right? And then you capture that something has changed information here in the sync table, and then this powers the Hasura kind of quote unquote cache update, right? And so as soon as there's an insert here or an update here, the appropriate entity here gets updated, right, via that event trigger. The nice thing here is that you can actually, because the sync event kind of keeps track of when it was last synced, when this was created, and so you can see a delay, what your typical kind of delay is whenever there is a synchronization, whenever a synchronization event needs to happen, right? And so that typically ends up being, from our observations, maybe about 2 to 3 seconds, right? You can optimize that a little more, but that's kind of the time delay that you would have in an event being published, and then everything getting updated. It obviously depends on your existing API and stuff like that. So that's kind of what this piece looks like. I'll just do another quick look at what it looks like to actually implement a particular mapper. So let me just share that as well. All right, cool. So the work that's required to set this mapping up, right? Because it's custom to your API, it's custom to a model that you have, is you implement a TypeScript interface that essentially has 3 keys, right? To help keep that data in sync. So you implement just those 3 pieces and the synchronization gets set up, right? So that's kind of what the data sync Lambda does. And just to show you what that interface looks like, let me just head to VS Code here. It's basically implementing this interface here, right? It's first a query that knows how to fetch the raw data from your existing API. Second, an upsert mutation in Hasura. So that will be an upsert into Hasura to the Hasura kind of, again, quote unquote cache. So you implement this upsert and you add in a GraphQL query here. And then you have a delete, because you might have a delete operation, you want to delete an entity from the cache. So you have a delete operation here, and that's a delete mutation. Again, these mutations are available automatically with Hasura, right? So as soon as you created a model, so as soon as I created the build model in Hasura Postgres, I automatically get an upsert mutation and a delete mutation, right? And then, and this is the critical part, this is a pretty, this is intended to be a simple function that allows you to map the API response into what you want to see in the Hasura model, right? Because sometimes you might not want to have a one-to-one mapping from your API model to what you have in the Hasura model, right? You maybe want to transform something, you want to encrypt the ID, you want to hide some data, right? Whatever it is, you kind of, you can do that mapping here so that you can map that response, right? It basically takes a key value, like an object, and spits out another object, right? Which is going to be what gets absorted into Hasura. So you implement that. It usually would take, maybe for a new model that you have, it would take you between 20 to 25 minutes to set this up for a new model, right? So that means per existing API kind of object type that you want to bring into a Hasura style thing, it should take you between 20 to 25 minutes to go in, create the Hasura model, write the upsert query, write the delete query here, and then set up the mapping, and then you're essentially done. And as soon as you start inserting events into the sync event table, everything kind of picks up from there. This we'll be publishing this as a open source kind of a module that you can run with instructions on how you can run this Lambda yourself. And so we'll be sharing that with you folks. Let me just quickly head back to the presentation to wrap that up with, in terms of caveats of when this works and when this doesn't work. So let me just share that with you here. All right, so this works when there are a few conditions, right? It doesn't work if you can't tolerate these conditions. The first is your existing API exposes business objects that can be queried by an ID, right? That's what you want to do with your existing API. There are objects there that can be queried by an ID, because that's what the synchronization system will use to query that raw ID and then populate the Hasura model, right? The second is that your existing API can emit events for business objects that are being changed, inserted, updated, or delete, or they are being published to a queue that is being then sent to Hasura, or you have the tolerance to say, it doesn't get updated too frequently, we'll just do a nightly cron or a 2-hourly cron or whatever, right? Again, it's just very similar to kind of a materialized view pattern, right? Where you're like, hey, I can incrementally maintain the materialized view, right? Or I can just refresh the entire materialized view every few hours or every day or whatever, right? The third is that you can tolerate a little bit of this cache inconsistency delay from when this update happens in your system of record to when the update shows up in Hasura, right? In most cases, this works well. This is totally fine to do, but that is a caveat here. Because it's not transactional. These are two completely independent systems. The fourth here is that the model that we're also setting up is when you're reading from Hasura, you're still writing to your existing API. You're still probably sending mutations, and you're maybe mapping those mutations with actions or remote schemas, sending that to your existing API. So you're mapping all of your mutations there, and then you're just doing the read from Hasura when you're reading that data, right? And then the read API can then have relationships and permissions and all of the stuff that you would get from Hasura. So that's a quick look at this. We'll be sharing, we'll be open sourcing the data sync module soon. It's already open source. We'll just be packaging that together so that you can check that out and start trying it out and letting us know if this is useful to you, and getting back to us with any feedback that you might have. All right, that's it from me. I'm going to pause because we're probably running out of time.
No, that was fantastic. And yeah, I mean, I can think of just a bunch of cases where that would be actually super, super useful, especially to cut down that latency for the lookups. That's awesome. We did have one question. You did answer it regarding about what if your backend system doesn't actually have the ability to emit events. In that case, they would use the cron approach that you mentioned, where they could just sort of say, we have a tolerance that we're allowed, that we can say, yeah, every nightly or every few hours, or yeah. So fantastic stuff. Really, really cool. Thanks so much for giving that straight from the brain of the CEO demo there. That was pretty cool. And also shout out to Gavin there, because one of our favorite little wizards behind the scene on some of those kind of things as well. So big shout out there. We will move on with our next demo because we do have a full agenda today. And so Ram is going to be giving us a really cool demo today about preview apps with Hasura and kind of a fast way to try things out. So this will be super exciting. Ram, you want to come on screen here and share your screen with us? Okay. Hey, here we go. Great.
Okay, great. So, hey everyone, I'm Ram and I work with the Cloud App team. Today, I'm going to show you how to quickly create preview projects using a new YAML Builder. Firstly, let me explain why you need this feature through an illustrative example. I am running a home-cooked food delivery app hosted on Hasura Cloud. In my local dev environment, I have prototyped a live delivery tracking feature. Before deploying the new feature to production, I want to share a prototype with my team. This is where preview apps will help me. Let's first watch preview apps in action. So this is the application I have hosted on Hasura Cloud now. It has a few APIs like dishes, order items, orders, and so on. And in my local Hasura instance, I've prototyped a new API for live deliveries called deliveries. So now I would want to create a prototype that can be hosted on Hasura Cloud so that my other teammates can use it and build stuff on top of it. So I've already set up preview project workflows in my GitHub repo. So creating a preview project out of this is as easy as creating a PR. So let me just go ahead and create a PR. So I'm on a feature branch, and as you can see, there are some changes to the metadata and migrations. Let me add them to a commit. And I'll push. Okay, so my changes have been pushed. Let me go to my repo and create a pull request. Compare and pull request. A pull request has been created, and you'll see that a new workflow has been triggered. This workflow is going to create a Hasura Cloud app, which is based on the current state of the repo. So this workflow takes about 3 minutes to complete. While this is going on, let's see how we can set up our own preview app workflows. So to set up your own preview app workflows, you would need to fulfill a few prerequisites. So you would need a local Hasura instance, of course, linked to a GitHub repo, and you would need an ephemeral database that is accessible online. The URI of this database would be added as a secret in your GitHub repo. And you would also need a Hasura Cloud personal access token. This too would go into your GitHub repo as a secret. Once you fulfill the prerequisites, you can use our YAML builder and create your GitHub YAML. So this is the YAML builder we have now. And to generate a YAML of this, you need to fill a form with some basic information, like the repository name and the directory in your repo in which you have the Hasura data, and you need to provide the region in which your Hasura Cloud preview app will be deployed. So it could be a free tier region or a standard tier region. If you choose a standard tier region, you would need to have a payment method set up. So let me choose a free tier region. And you can also enter the environment variables that you want to be added in your Hasura Cloud preview project. And you also have the option to set up databases, which I'll enable now. So to connect your app to a database, you would need to provide the connection URI of your database. This URI can be linked from the secret that you set up in your GitHub repo. So I'll use this template to make sure that the Postgres connection URI is picked up from the GitHub repo secrets. And you could also add some environment variables related to your database. Okay, I'll also go ahead and create a new environment variable for my Hasura Cloud project called PG database URL and link it to the Postgres connection URI secret. And once you've filled in all the details, you just click on the generate YAML button, and ta-da, you have your YAML generated. Now, all you need to do is copy this YAML and paste it in your GitHub repo under the folder .github/workflows in a file called Hasura Cloud Preview App.yml. So once you do this and you push this code to your repo, any subsequent pull request that is made to your repo will automatically trigger the creation of a preview project. Okay. So let's go back to our repo and see if our preview project has been created. Yes, as we can see here, the workflow has completed, which means that our preview project must be ready right now. So yeah, a new project has been created, and let's launch it. So you should be able to see the new API available in the preview project. Yes, there's one more API here for deliveries, and compared to the base version, which doesn't have this, we have the prototype, which has a new API. Now you could share your project with your teammates or anyone, and they could use it to build more features on top of it. And that's how it's done. Thanks for watching. Please drop in your questions and I'll be happy to answer them.
That is so cool. Like that flow is going to save a lot of people some time. I'm going to have us actually move on to the next demo, though there is one question in chat. So Ram, if you don't mind taking that and being able to respond in the chat. Basically, the question is there a way to also configure automatic seed application or applying seeds with that workflow as well? So maybe you can take that in chat and let them know what your recommendation is there. But thank you so much. Great demo. And that feature is going to really save a lot of people some time. Super cool. Next up, we have Solomon. Solomon, why don't you come on screen here and share your screen with us? And we're going to see some updates to the REST connectors.
I'm just going to give like kind of a brief overview of our templating language Critty and how you can use it for creating REST connectors and some new features that we recently merged in. So for anyone who doesn't know, the REST connectors is a feature of the search engine which allows you to modify the outgoing request or incoming response from your actions and event triggers. So what that means is that if you have some third-party API that you don't have control over you don't have control over it. You can't change its schema, or previously you would have to use some sort of intermediate Lambda or whatever web server to sort of map the result from a GitHub, or sorry, from a Hasura action or an event trigger to whatever schema the third-party API needs to receive. But with REST connectors, you can now move that mapping into the Hasura engine by using this templating engine called Critty, which we've developed. So Critty is just a JSON templating language that is expression based. So it always evaluates to valid Critty, or sorry, valid JSON. I'm assuming that you have a valid Critty expression. It always evaluates to a valid JSON expression. And it's a pretty small language. It doesn't have like variable binding or lambdas or anything like that. So it's pretty hard to write a Critty expression that's going to break. Really, the only real way would be a syntax error or invalid path lookup. But so now let me just really quickly show you a little bit of a live demo with it, and then I'll just the absolute basics, and then I'll show you the new features. So what we're looking at here is a request to the metadata API. I'm running Hasura locally, the open source version locally. This is on the main branch, and I'm calling the metadata API where we have this action called test webhook transform, which is something I use this all the time during development. It's a really helpful way to sort of simulate, give yourself like a simulated action or whatever for testing out your webhook transformation templates to make sure they're working as you expect. Basically, the way this works is you describe a sort of, in the arguments, you describe a like dummy HTTP request that would be going out. You give it, for example, you could give it like a URL and a body, and you can also add, other parts to it, but this is enough for this demo. And then you provide a request transformation. And then it doesn't actually call this API, it just will perform this transformation on the described request here, and then the result will be just what the shape of the request that would have been sent out. So this is really nice for debugging things. So for example, right now I'm running it, and this is my URL, and this is a GET request by default. So I'm going to transform the request method to post. And I'm just going to leave, and I'm using a Critty template for the URL, and I'm also using a Critty template for the body. But these templates are just going to do a path lookup on the actual URL and the actual body. So the only thing this is going to do is change the method. And so I can see the method became post. Here's the body is the same as I had it over here, and the URL is the same. So now we can kind of mess with this a little bit. So for example, if we wanted to say, add some path here, we could change the URL. You can do just sort of standard string interpolation stuff here, where so now the path is /foo, or the URL. And then we can do, we can interpolate in something from the body. So like base dot, so we're in the body. Now we're going to the input dot arg1 dot username. And I maybe made a typo, invalid path. So input, sorry, base, oh, sorry, that's a typo. It should be body here. Okay, so now we've got foo/Solomon here. And but that's this is a great place to demo one of the new features. So actually let's do that in the body. But so we can so say we wanted to just, let me get rid of this right here, but like so Critty provides a number of different operations that you can perform in addition to path lookup. Let's look at them really quickly over here. So you can do path lookups. You can loop over arrays. You have conditional statements. And then we've added a couple of new features that I want to show you. So let's do that same path lookup, but let's put it in the body so it's a little bit easier to see. Bodies dot input dot arg1 dot username. So now the body is just my name. But oftentimes it's the case that that a REST endpoint will produce some there's variable, there can be optional fields or fields that aren't necessarily going to be available every time you call the request. So or sometimes even, or in the case of like an action or something, perhaps like some piece of data that's not always going to be available in here. So what we have, we've added a defaulting operator, which allows you to replace any missing value with some default value. So for example, what that means is that if we have a null value, then we can use the defaulting operator to replace it with true. And if this value was something else, like my name, you'll get your name. So that's pretty nice. So that means that if you have some sort of null value in your data, you can always have some sort of default value for it. And this operation is associative, so you can chain these if necessary. So this could be another lookup. This could be like some body lookup, and then you could body, and then you could chain it again and have a default value here or whatever. And it'll just cascade through these things. Or sorry, wrong operator, wrong symbol. But so then another useful thing is we've added a optional path lookup, which looks like this, where we have a question mark. And what that does is it's in a sense, it's a sort of way of catching an exception in the path lookup. Because currently, if you were to try to look up body dot input dot arg2, this is going to throw an exception. And so we're going to get an invalid path error. But if we use the optional lookup on arg2, then we should get a null there. And now you can chain that with the defaulting operator, and you could say if arg2 is invalid, then use arg1. And so now, because arg2 wasn't available, was not present, was undefined, we defaulted it to null with the optional lookup, and then we caught it and replaced it with null, and then we defaulted it to arg1. So we have this fallback behavior now. So we can this allows you to do a lot of really nice stuff, like dealing with like non-determinism in your data, like if you don't know that a field is present or if it's going to be null or not. What else is new? So those are two pretty big features. There's also, we've also oh yeah, so sorry. So optional chaining also works for array lookups using the array square bracket syntax. So you can use that in either case. And then oh yeah, one more feature. So like so I don't know if you've noticed, but I don't know if anyone uses feature much, but there's this version 2 field here. And what we've done is we've decided that there's actually, like, we've been thinking about how body transformations work, and really there's like a number of different things that you can do when operating on the body of a request. One of them is to perform like a template transformation using Critty. Another one might be to convert the format from to build some other non-JSON body, such as like URL form encoded. Another one might be to just remove the body altogether. And so we've added, so in version 2 of the schema, we've added this envelope to body where you specify what type of action and then specific fields for that action. And in the branch I'm working on here, there's only 2 actions. There's transform and then remove. But we have another branch where we've added like a conversion for form URL encoded, and we'll probably add more in the future. But for example, if I do the remove action, then you just get a null body. You could do the same thing with a Critty template, but it's a little bit it's not as nice because you'd have to do this weird thing where you have a null value inside of a Critty template to get that, which is kind of weird. So we just have instead we now have this explicit remove action, and we're thinking about other actions we can add. We have a branch where we've added form URL encoded transformations, and I'm trying to think about if it makes sense to do sequencing of these actions, such as like do a Critty template transformation on JSON and then convert it to form URL encoded. But yeah, there's a lot of possibilities there that could be interesting. And I'd love to hear back from any end users if you have thoughts or feedback on these features. So as usual, please submit any questions you have in the chat, or if you want, you can write an issue on the repo. We'd love to get feedback because this feature is for you guys. So thanks very much.
Very cool. Thanks so much. Because that is actually, I think I was the #1 requester there for that feature. And it's really great having that in there. So super cool. We're going to go ahead and move on with the next demo here because we are running a little bit short on time. I'm going to have to do a little bit something kind of new here. I'm going to actually make a teaser for the other Hasura demo that we were going to be showing today about multiple JWTs. We're going to do that one next month. It is really cool, and there's so many great pieces in there, but we promise we'll make it worth your time. So I'm sorry I have to do a change up. We just had too much in the agenda today. So we're going to have to push that one to next week, but I have a really great community demo for you today. And that is from Ace Sedai. And he has a special wrapper around the open source Hasura endpoint for doing kind of a parsing of GraphQL subscriptions, which he refers to as the Delta Gateway. So this is a really cool demo. I'm going to go ahead and let this video play here. And without further ado, we'll let it go.
Hello, my name is Ice, and I'm here today to share with you a project I've been working on called Delta Gateway, a GraphQL proxy with incremental subscriptions. Delta Gateway is a Node.js GraphQL proxy that lets you add generic middleware to your stack. It also supports incremental subscriptions by extending Hasura's subscription route. Here, I have a sample application built in React using Apollo client to help demonstrate the differences between a regular Hasura subscription and a Delta Gateway incremental subscription. The Hasura subscription and the Delta subscription use separate GraphQL WebSockets to ensure that we don't receive conflicting updates whenever we receive updates for a particular subscription. For this demonstration, I have a simple schema composed of authors and books. Right now, there are no authors nor books in the database, but whenever we seed the database and add authors, we can see that the subscriptions both receive updates. Here, we can expand the data, and we can verify that both the regular subscription and the Delta subscription have the same cache value. At the bottom, you can see the data that the regular Hasura subscription returns and the data that the Delta subscription returns. These look a little different because the Delta subscription uses the library called JSON diff patch to determine what patch should be sent to the client to update the client state to reflect what the server state should be. There are a couple of more points of interest in this demo. Here we have the last data sent by the regular Hasura subscription versus the data sent in the Delta subscription, and we have a cumulative running total for each. As we can see right now, the Delta subscription has sent more bytes over the wire, but let's keep an eye on this as we proceed through the demonstration. Let's use the sidebar to update a random author. This will change the author's name. As we can see, the new author name is new author name 9245. If we scroll down in the regular subscription, we can see the name has been updated. But if we look at the Delta subscription, it looks a little different. This is because the JSON diff patch identifies an element by its type name and ID and uses that to update only the attributes that have changed. In comparison, a Hasura subscription resends the entire results set whenever you update any attribute in the selected set. The same holds true for nested resources. If we update the name of a book, we can see The Hasura resends the entire result set with a new updated book title here, but JSON diff patch only sends an update for the book that's been updated. This also works if we decide to add or remove a book. If we take a look at the total data sent for the regular subscription versus the Delta subscription at this point, we can see that the Delta subscription has sent fewer bytes over the wire. Now, let's see what happens if we perform 100 random actions. This will update an author name or book title, add a book, or remove a book. As you can see, both the regular subscription and the Delta subscription receive an update about once a second. As you can see, after performing 100 random actions, the dataset for the Hasura subscription and the Delta subscription is identical. However, the total data sent over the wire for the Hasura subscription is about 80,000 bytes versus 25,000 bytes for the Delta subscription. It's also important to note that as the size of the dataset increases, the Hasura subscription has to send more data over the wire per update. The Delta subscription, on the other hand, since it only sends patches, has a near constant data size. It's also important to mention that unlike other methods of trying to optimize the network bandwidth of Hasura subscriptions, the Delta subscription method handles removing items from a dataset as well as updating and creating them. This is a common problem you run into when you're trying to return only updated data by an updated at timestamp. Another important feature of the Delta Gateway is the ability to resume subscriptions. If we refresh the page, we can see that whenever the Hasura subscription returns its initial dataset, you get about 7,100 bytes back. However, the Delta subscription is able to take a last updated timestamp and resume the subscription from that point. The gateway is able to identify from the timestamp sent by the client that there are no new changes and that it doesn't send any more data to the client. You can continue performing actions, like updating an author again, and it resumes as you would expect. Finally, let's remove all the authors from the database. After removing all the authors, we can see the regular subscription returns us a blank author key. The Delta subscription has a little more data because it tells it to remove everything inside the cache, but this is something that can be optimized in the future. If you've enjoyed this demonstration and wish to learn more, the code is available on GitHub. Thank you for watching, and a big thanks to Hasura for their wonderful work.
Yeah, so he's got a much more technical overview. It's like 30 minutes that he will make available as well. And you can find him on Discord, and he'll share that with the community. So super cool stuff. Thank you, Ace, for that great bit of content. All right, so a couple of last minute updates. I appreciate you sticking around so long. Wanted to do another shout out. We have the Hasura Data and API show that we do every week on Tuesdays. We go through everything from building external APIs with partners like Stripe, which will be our guest this coming Tuesday, or building application dashboards. We have a lot of different great pieces of content in there. So I would recommend you join and see that. They're also on YouTube, so it'll be a lot of fun to see you around there. And it's a fun place to just kind of nerd out about Hasura and the ecosystem as a whole. The big update that we have coming up here is actually that HasuraCon is launched. We're really excited about that. And the CFPs are now actually open. So if you would like to present something about your use of Hasura and what you like using with Hasura, like that would be a great place to hear from you and show the world what it is that you do with Hasura. And we'd love to have you as a speaker. So definitely submit your CFPs. And we would love to see you there on June 28th. So this is going to be a lot of fun. This is like Hasura Family Day. It's one of our favorite events in the year. So super excited about seeing you there. And then the next community call is going to be March 31st. If you've got something you'd like to share or demo, let us know. We're on Discord. This is the place to kind of reach out to us. And if you've got like something that you're building or a cool tool or something you'd like to just show people, that is a great place to let us know as well. And that's the link for Discord there. So discord.com/invite Hasura. I'd highly recommend you join that because that is the place to interact with all of us. And it's a lot of fun. So if you have any feedback on today's call, you'll be receiving an email that has a link for this as well. But if you have anything that makes you want to just kind of reach out specifically about, you can use any of these links on the slide here. But with that being said, and us being over, I just want to say thank you again for joining us. Thank you again for being part of this ride that we've been on so far. It was a great call today. And for those of you who are in the Far East there, stay safe. We love you all, and we will see you at the next community call. Have a good one. Bye.